Hello guys, today we are going to discuss about digital logic system and its simplifications techniques. Basically, there are two kinds of simplification techniques. One technique is using a special Boolean algebra techniques like using implication or commutative or Boolean algebraic rules and calculation, but we will have discussed it already. But now today we are going to discuss a new thing is a simplification using a K-map or a coordinate map is also known as a coordinate map too. So coordinate map is quite really easy and than that Boolean algebra techniques because we have to remember the formulas of Boolean commutative property, associative property, while the mapping technique is quite easy. K-map technique is quite easy than that Boolean algebra techniques. So that is really quite important for simplification of any circuit using a digital logic system, using a digital logics, using a logic gates. So let's now start about digital K-map simplification. Consider a scenario that you have a function that is 1 and 3 numbers, 1 and 3 numbers, and let's break down it into a binary numbers in zeros and one form in a Boolean form. First of all, we have to break down any functions into a binary form, zeros and 1. If there is x, then it means that is 1, and if there is 0 x, or if there is x naught or x complement, then that means that is 0. So consider there is a binary of 1 is 0 1, and while the binary of 3 is 1 1. So we will draw a map using a two variable, as we know that there are two functions, so we use a truth table of 4 variables. We are going to get output of 4, where we see that 1 and 0 verifies the condition 1 and 0, as we see before that their function is 1 and 3. So here we can see the truth table that 1 and 0 is the truth conditions of 3, and 1 is a fourth. Let's edit it out. It might be 4 here, 4 and 3. Okay, so it's my mistake, it's okay. So function will be 1 here and here, while the function is going to be a 0 and 0. Remember that this is in a mean terms. In the mean terms we will put 1 on there, as we know a is equal to 1 and b is equal to 0, b not 1 and 0, so it verify 1 and 0, so we put 1 here at that position. Now here is 1 and 1, so a is equal to 1 and b is also going to be 1, so we put 1 here. Now what we will do is we are going to make the group of these two, and we will make the group of these two and then verify the condition that similarities, where is the similarities between both of these two groups. If there is similarity, as you can see a is similar, in this case have both 1 1, while b is 0 and 1, so we are going to detect, so we are going to detect b, and we cut it and we write the function simply a, and we, as you can see, we have simplified our function into a, while we have before that we have two variables, and now we have one variables left, and we have already simplified our function. Thank you for watching. Subscribe my channel and keep watching.